Screen is visible, students?
Yes, sir.
So,
Okay, okay, fine. Today we'll be starting with a new module, that is module number 3. And the first topic that we are going to deal with is Poisson's and Laplace equations. Here we are going to derive these equations, Poisson's and Laplace equations. Now, the first thing that we have to know is that till now we have obtained the electric field intensity and electric flux density, that is E bar and D bar, using Coulomb's law and using the Gauss law, right? But there are certain charge distributions, right? It is easy to find these charge distributions theoretically, but practically it is difficult to find the charge distribution along the surface, right, and the potential along the surface, so that we will be able to find the electric field intensity and the electric flux density. Practically it is very difficult to find the values of charge distribution and potential at the surfaces, but practically it is possible to find the values of potential and charge distribution at the boundary. Just as we studied the boundary condition in our previous module, we can find out the potential and charge distributions at the boundary between two media. That is possible. That is possible. Okay. So at the boundary, it is possible to obtain the charge distribution and the potential. Once we obtain the charge distribution and the potential at the boundary, we can easily use it to extrapolate, or we will be able to find out the charge distribution or the electric field intensity and the electric flux density throughout the surface. So such of the electrostatic problems, they are called as boundary value problems. That means we are finding the values of the potential and the charge distribution at the boundary. Once we obtain these values at the boundary and find electric field intensity and flux density, we can find out for the entire surface. Okay, so this is the idea behind the Poisson's and Laplace equations. And these boundary value problems, that is, such boundary value problems can be solved mathematically. They can be solved using the equations called as Poisson's and Laplace equations. They can be solved using the equations called as Poisson's and Laplace equations. These are the equations called as Poisson's and Laplace equations. In this class, we'll be in this particular module, we'll be deriving these two equations, Poisson's and Laplace equations, and then after deriving these equations, we will be using the fundamentals that we will be obtaining from these Poisson's and Laplace equations in our other topics that we are going to study in this module, the application part of the Poisson's and Laplace equations. Okay, this is the idea behind the Poisson's and the Laplace equations. Now, from the Gauss law in point form, it is possible to derive the Poisson's equation. Let us consider the Gauss law in point form. The Gauss law in point form is given by del dot d bar is equal to rho v. Where we have come across this equation? This is the Gauss law in point form. It is called as Gauss law in point form or Gauss law in differential form. Differential equation it is. Gauss law in differential form or Gauss law in point form. Okay. And this equation is also called by another name. What is that? What is the other name for Gauss law in point form? What is the other name? Can anybody recollect? It is called as Maxwell's first equation. Maxwell's first equation. Okay, that is Maxwell's first equation, or it is also called as Gauss law in point form. Both are one and the same. Where d bar is flux density and rho v is volume charge density. That is, divergence of the electric flux density is equal to volume charge density. This is the equation of the Gauss in point form, or it is Maxwell's first equation. We know that d bar is equal to epsilon into E bar. We know that d bar is equal to epsilon into E bar, or d is equal to epsilon into E. Substitute this d is equal to epsilon E in the equation number 1. Del dot, instead of d bar, I'll substitute it as epsilon E. Therefore, del dot epsilon E bar is equal to rho v. Take it as equation 3. Now we also know the relationship between electric field intensity and the electric potential. What is that relation? One of the important relations. E is equal to minus del V. That is, electric field intensity is negative gradient of the electric field potential. Electric field intensity is negative gradient of the electric field potential. Okay. Now substitute this equation 4 in equation 3. Okay. Substitute this equation for E bar in equation 3. What we will get? Del dot epsilon of, instead of E, I will substitute this equation, minus del V, that is equal to rho V. That is equal to rho V. Okay. Now what I will do? I will take minus epsilon outside because it's a constant. So I'm taking minus epsilon outside this. I'll get minus epsilon of del dot del V is equal to rho V. Minus epsilon of del dot del V is equal to rho V, or del dot del V is equal to minus rho V by epsilon. Del dot del V is equal to minus rho V by epsilon. Now what is this del dot del V, students? Del dot del V is what? It is del square V. Is it not? We have studied this. Del dot del V is nothing but it is del square V. So write it. There is del dot del operation. It is called as del squared operation. It is denoted by del square. It is denoted by del square. That is, it is given by del square V is equal to the RHS, that is minus rho V by epsilon. Minus rho V by epsilon. Take it as equation 7. This equation 7 is called as the Poisson's equation. It is called as Poisson's equation. Del square V is equal to minus rho V by epsilon. Suppose if we consider the region where the charges are null. That means if we consider the charge free region, in such region the volume charge density is rho V, that is equal to 0. Right? If you are considering the charge free region, in such regions, right, in a certain region, what will happen? The volume charge density rho V will be equal to 0, right? Which is true for the dielectric medium. Correct? For the dielectric medium, there are no free charges. All are bond charges. They are bonded to each other. There are no free charges in the dielectric medium. Correct? And hence the volume charge density is 0 for the dielectric medium. Correct? That means this rho V is 0 for dielectric medium or for charge free region. And hence, if we substitute rho V is equal to 0 in equation 7, we'll get del square V is equal to 0, which is the equation for charge free region. This is the special case of Poisson's equation, which is called as the Laplace equation. First, we have to derive Poisson's equation. From Poisson's equation, we have to state that rho V is equal to 0 for charge free region or for dielectric medium, and hence from the Poisson's equation we'll get Laplace equation as del square V is equal to 0. So again, this del square operation is called as the Laplacian of. For the Laplace equation, this del squared operation is called as the Laplacian of. I hope you all are following here, students. Yes. So this is one of the important derivation, students. Many times it has been repeatedly asked in examination to derive the Poisson's and Laplace equations. Okay, from the Gauss law in point form. Derive the equation of Poisson's and Laplace starting with the Gauss law in point form. So you have to use the Gauss law in point form, that is del dot d bar is equal to rho V, and through these steps you should arrive at the equation. The first one, Poisson's equation, del square V is equal to minus rho V by epsilon, and the second one, the Laplace equation, del square V is equal to 0. Clear here? Is this derivation clear, students? Any difficulty here in this derivation? All of you understood this derivation?
Yes, sir.
Okay. Rohan, did you understand this derivation? Rohan Timsani?
Yes, sir.
Okay. Sadashiv Gari? Sadashiv? Understood the derivation? Sagar? Sagar? Talikeri? Sania?
Yes, sir.
Is the derivation clear, Sania?
Yes, sir.
Okay, fine. Then we'll move to the next topic. Next is del square operation in different coordinate systems. This is like we have to use this del square operation in solving various numericals. That is where this is helpful. Let us try to find out the various equations of del square in various coordinate systems. In Cartesian coordinate system, del V. What is del V, students? That is dou V by dou x ax bar plus dou V by dou y ay bar plus dou V by dou z az bar. This is del V. There is no dot operator, remember here. It is only simply del V. So del V is dou V by dou x ax bar plus dou V by dou y ay bar plus dou V by dou z az bar. If it is say del A, then what it will be? Dou A by dou x ax bar plus dou A by dou y ay bar plus dou A by dou z az bar, like that, depending on the vector given here. Okay. Now we want del dot del V because we have to find out del square V. That is our which equation? Laplace equation. Correct? Del square V. So del dot del V. What is del? Del is dou ax bar by dou x plus dou ay bar by dou y plus dou az bar by dou z. That is our del. Or del is equal to dou by dou x ax bar plus dou by dou y ay bar plus dou by dou z az bar. If we take the dot product of del with del V, if we take dot product of del with del V, this equation, then what we will get? Del is dou by dou x ax bar. So ax bar dot ax bar will be 1 dou by dou x of dou V by dou x plus ay dot with ay. Dou by dou y of ay. Del is plus y component is dou by dou y of ay. So ay bar dot with this ay bar, it is 1. So what will remain? Plus dou by dou y of dou V by dou y plus next is z component. Z component of del is dou by dou z of az bar. Here z component of del V is dou V by dou z az bar. So az bar dot az bar will be 1 and dou by dou z of dou V by dou z. This is what we will get for del dot del V. Therefore del square V will be equal to dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Take it as equation 8. This equation for del square V, it is the Laplace equation in Cartesian form because we are using the Cartesian coordinates x, y and z. Next is the Laplace equation in cylindrical form. That is del square V is equal to 1 by r dou by dou r of r dou V by dou r plus 1 upon r square dou square V by dou phi square plus dou square V by dou z square is equal to 0. This is the Laplace equation in cylindrical coordinate system. Which are the cylindrical coordinate system, students? Which is the cylindrical coordinate? Cylindrical coordinate. In Cartesian, there is x, y, z coordinates. In cylindrical system, what is the coordinate? In cylindrical, yes, anybody? Coordinate of cylindrical system. First module, try to recollect. Yes. Coordinate of cylindrical system is what? Coordinate of Cartesian is x, y, z. Similarly, coordinate of cylindrical system is what?
Rho
Coordinate
5
of
and z.
It is? Yes.
Rho 5 and z.
Rho phi and z or r phi and z. Anyone you can take. Follow one convention. Either you take it as rho or r. Right? In some books they are giving it as rho. In some books they give it as r. Okay. Follow one convention and use that convention throughout so that there is no confusion. Okay. So Cartesian system is also called as rectangular system. Note that, students. Cartesian system is also called as rectangular system. Okay. And in cylindrical system, the coordinates are r, phi and z or rho, phi and z. Okay. So this is the equation for the cylindrical coordinate system of the Laplace equation, del square V equation. Similarly, we can write the equation for Laplace in spherical coordinate system, and it is del square V is equal to 1 upon r square dou by dou r of r square dou V by dou r plus 1 upon r square sine theta dou by dou theta of sine theta dou V by dou theta plus 1 upon r square sine square theta dou square V by dou phi square is equal to 0. Which are the coordinates of spherical system, students? Spherical system coordinates. Yes. Coordinate of spherical system. Prathamesh.
R theta phi, sir.
R, theta and phi. Very good.
Phi.
R, theta and phi. Okay. You will have to remember these equations, students. Very important. These three equations. Equation number 8, 9 and 10. That is, one is for Poisson, another for cylindrical, another for the spherical system. Because these equations you will have to use when solving the numericals. Okay. Let us solve a numerical of the today's class. Determine whether or not the following potential fields satisfy the Laplace's equation. The given equations are V is equal to x square minus y square plus z square. Second one, V is equal to r cos phi plus z. Then third one, V is equal to r cos theta plus phi. Note down the example, students. Note down the statement of the problem. Note down the statement. We'll solve the example. This is an examination problem, students. What all problems we will be solving today, they are collected from the video question papers. Did you all take it, students?
Taken, sir.
Yes, sir.
Okay. Okay, right. Read the example. Determine whether or not the following potential fields satisfy the Laplace's equation. They are asking to find out whether the equation for the potential or the potential voltage equations here given, whether they satisfy the Laplace equation or not. Laplace equation, we know that it is del square V is equal to 0. That means once we find del square V, we have to check whether the del square V for the given equations, that is first equation, for example, it is V is equal to x square minus y square plus z square. For this, once we find del square V, we have to check whether it is equal to 0. If it is equal to 0, that means it satisfies the Laplace equation. If it is not 0, that means it does not satisfy the Laplace equation. That is the concept behind this. So first one, V is equal to x square minus y square plus z square. We know the equation for del square V. Just now we have gone through that. This is the equation for Cartesian. Del square V is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square is equal to 0. This is the equation for del square V. Yes. Write it. Del square V is equal to dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Now find out the double derivative of V. Double derivative of V, students, with respect to y, with respect to x, and with respect to z. Okay. That is dou square by dou x square of x square minus y square plus z square plus dou square by dou y square of x square minus y square plus z square plus dou square by dou z square of x square minus y square plus z square. Find the double derivative and tell me what you will get. Equation is V is equal to x square minus y square plus z square. Differentiate with respect to x 2 times, differentiate V with respect to y 2 times, plus differentiate V with respect to z 2 times, and tell me what is the answer. 2 times differentiation you have to do.
2, sir.
2 you will get. Very good. See here how we are getting the answer. Dou by dou x square of dou square by dou x square of x square minus y square plus z square. So first time derivative of this equation is 2x first time derivation. Then first time derivation of with respect to y of this equation will be minus 2y. Then first time derivative of the given equation with respect to z, it is, so x and y are constant, with respect to z means it will be 2z. This is the first derivative. Then once you take the derivation the second time, dou by dou x of 2x, so it is 2. Dou by dou y of minus 2y is minus 2, plus dou by dou z of 2z is plus 2. Then it is 2 minus 2 plus 2. So you will get how much? 2 minus 2 is 0, so it is 2 you will get. Okay, answer is 2. It indicates that del square v is not equal to 0. Del square v is not equal to 0. So whether it satisfies Laplace equation? If del square v is not equal to 0,
No, sir.
no. Yes. So del square v is not equal to 0. Hence the electric field V does not satisfy the Laplace equation. Okay. Note down quickly these steps, students. Is it taken, students?
Yes, sir.
Yes, sir.
Okay, we'll move further. Next, part B. What is the equation that they have given? V is equal to r cos phi plus z. This is the equation. We have to consider this equation now for part B. So V is equal to r cos phi plus z. Let us find out in cylindrical coordinate system. It is del square V because it is r, phi and z. So it is in cylindrical coordinate system. The first and foremost thing when any example is asked, when any numerical is asked, you all have to find out whether the given coordinates are in Cartesian or in cylindrical or in spherical. If we look into this equation, r cos phi plus z, so they are given in cylindrical system. R is in r, phi and z, they are coordinates of the cylindrical system. Hence, we have to use the Laplace equation which is in cylindrical system for the cylindrical system. That is the Laplace equation what we discussed now. The del square V is equal to 1 by r dou by dou r of r dou v by dou r plus 1 upon r square dou square v by dou phi square plus dou square v by dou z square is equal to 0. We have to use this equation. Write it, the same equation. So written the same equation here for del square v. Then this inner term dou v by dou r. Let us find out this dou v by dou r. That is dou by dou r of v. V is r cos phi plus z. Then if we differentiate with respect to r, what we will get here? Cos phi. Right, cos phi is constant, so if we differentiate r with respect to r, it is 1. Differentiation of z is 0. Then differentiate v, this term, inner term. Find out all the inner terms first. Dou square v by dou phi square. First find out dou v by dou phi. That is dou by dou phi of r cos phi plus z. R cos phi plus z. So differentiate with respect to phi. That is taking r constant, so it will be minus r sin phi. Differentiation of z is 0. Then differentiate v with respect to z. Dou v by dou z. This dou by dou z of r cos phi plus z. Differentiate with respect to z is you will get 1 because r cos phi is constant term. Its differentiation is 0. Differentiation of z with respect to z is 1. Right. Now we have to substitute in this above equation. Therefore, what we will get? 1 upon r dou by dou r of r dou v by dou r. How much this will be? The first term. 1 upon r dou by dou r of r dou v by dou r. It is 1 upon r dou by dou r of r dou v by dou r. Dou v by dou r is cos phi. So r dou v by dou r means r cos phi. We already determined that dou v by dou r. Okay, just substitute here. So we have to find again dou by dou r of r cos phi. Okay, it is, remember, r is inside. Please don't remove it outside. So r is inside. If so, here what we will get? Differentiation of this. So 1 upon r dou by dou r of r cos phi. 1 upon r dou by dou r of r cos phi. 1 minute. One upon r, it is 1 by r dou by dou r of r cos phi. So it will be cos phi. Okay, yes. So it will be differentiation of r with differentiation of r cos phi with respect to r. Okay, so it is how much? Cos phi. It is cos phi. So this is differentiated with the r cos phi is differentiated with respect to r. So it is cos phi will get differentiation of r with respect to r is 1 r. Sorry, differentiation of r with respect to r is 1. So it will be 1 upon r cos phi. 1 upon r cos phi. Okay. So we'll get 1 upon r square dou square v by dou phi square. Next term in this term here, second term. 1 upon r square dou square v by dou phi square. That is 1 upon r square of dou by dou phi of, what is the equation we have got? Dou v by dou phi minus r sin phi. Okay, it is minus r sin phi. So what you will get here, students? Minus r sin phi with differentiate with respect to phi. So it will be minus r cos phi. Minus r cos phi, that divided by this r square. Right? So it will be minus cos phi by r. 1 r and 1 r will cancel. We will get minus cos phi by r. Now add all the three. Okay, that is 1 upon r. The one more term is remaining, dou square v by dou z square. We have got dou v by dou z as 1. What is dou square v by dou z square? Dou v by dou z is 1. Or how much will be dou square v by dou z square? Second derivative of 1. Second derivative of 1. 0. It's a constant term. Nice. So d square v by dou z square, dou square v by dou z square is equal to dou by dou z of 1. That is 0. That is 0. Right? Now add all these three, whatever we have got. That is del square v is equal to 1 upon r cos phi minus cos phi by r plus this term 0. So cos phi by r minus cos phi r, they will get cancelled. So you'll get 0. That means del square v is equal to 0. Hence the given equation v is equal to r cos phi plus z satisfies the Laplace equation. It satisfies the Laplace's equation. Okay. So this is the part B. Note down the steps, students, quickly. Note down the steps.
Taken, sir.
Okay, good. Next, third equation. Look into the third equation. What is given? V is r cos theta plus phi. V is r cos theta plus phi. They are given in terms of r theta and phi. Which system it is? R theta phi. Yes, it is which system?
Spherical.
Spherical system. That means we have to use the Laplace equation for spherical system. That is this equation. Del square V is equal to 1 upon R square dou by dou R of R square dou V by dou R plus 1 upon R square sine theta dou by dou theta of sine theta dou V by dou theta plus 1 upon R square sine square theta dou square V by dou phi square. This equation should be used. Let us use the same equation. Let's see how the problem. I have written the same equation here. Then I am finding the inner terms first. That is R square dou V by dou R. This term R square dou V by dou R. So it is R square into dou by dou R of V. What is the given equation for V, students, here? R cos theta plus phi. Substitute that. R cos theta plus phi. Dou by dou R of R cos theta plus phi is differentiation with respect to R. So it will be cos theta. Differentiation of phi is 0. Then sine theta dou V by dou theta. Inner term here. Sine theta dou V by dou theta. That is sine theta dou by dou theta of given equation R cos theta plus phi. Differentiate with respect to theta. So I'll get cos theta. So if R is constant, take it outside. So differentiation of cos theta is minus sine theta. It is minus sine theta. Differentiation of phi is 0. Then this is expanded. We'll get minus R sine square theta. It is minus R sine square theta. Please note that minus sign is missing here. Then the third one, 1 upon R square sine square theta dou square V by dou phi square. That is 1 upon R square sine square theta dou square upon dou phi square of the inner term. That is R cos theta plus phi. That is 1 upon R square sine square theta dou by dou phi. What is the differentiation with respect to phi of the given equation? R cos theta, this is 0. Then differentiation of phi with respect to phi is 1. So if we take a double differentiation, dou square V by dou phi square, it will be 0. Correct? Dou square by dou phi square. See, first derivative is we'll get 1. Dou by dou phi of 1. Okay. Then again, if we derivate that, we'll get differentiation of 1 is 0. Correct? So it will get this term, third term will be 0. Then whatever terms we have got, add them, students. We'll get del square V is equal to 1 upon R square dou by dou R. This one, 1 upon R square dou by dou R of R square dou V by dou R. What is R square dou V by dou R? R square cos theta plus 1 upon R square sine theta dou by dou theta of this next term. That is sine theta dou V by dou theta. Here we have got it as minus R sine square theta. So it is minus R sine square theta. Then again, find the differentiation here. 1 upon R square, differentiation of R square cos theta. So it is cos theta into 2R or 2R cos theta plus 1 upon R square sine theta. Then what is the differentiation of minus R sine square theta, students? Differentiation of minus R sine square theta. Yes. Differentiation of R square R sine square theta is how much? Yes. How do you find the differentiation of minus R sine square theta? So it is minus R is constant. Okay. Then differentiation of sine square theta with respect to theta is how much? It is of the x raised to n form. So 2 into x raised to n minus 1. So it is 2 sine theta. Then differentiation of sine theta is cos theta. Correct? So it will be minus R 2 sine theta cos theta. Minus R 2 sine theta cos theta. So here 1 R and 1 R will cancel. We'll get 2 cos theta by R. Then 1 R and 1 R will cancel. And so sine theta and sine theta will cancel. So we'll get minus 2 cos theta by R. So 2 cos theta by R minus 2 cos theta by R. This is how much? 0. Again, we are getting del square V is equal to 0. Hence, the given equation V is equal to R cos theta plus phi. It satisfies the Laplace equation. Satisfies the Laplace equation. Del square V is equal to 0. Hence, it satisfies the Laplace equation. Okay. Note down the steps, students, quickly.
Taken, sir.
Yes. Let us solve a simple example. Next one. Please note down this example. If the field of a region in space is given by E bar is equal to 5 cos z Az bar volt per meter, is the region free of charge? The field of a region in space is given by E bar is equal to 5 cos z Az bar volt per meter, is the region free of charge? Note down the statement. I will solve it. I hope everybody have taken the statement.
Yes, sir.
Okay. Read the question first, students. Let us try to understand what is given and what is being asked. If the field of a region in space, there is some region in space and its electric field intensity is given by the equation E bar is equal to 5 cos z Az bar volt per meter. This is the equation of the electric field intensity in the given region. Now they are asking, is the region free of charge? Whether that region where this electric field intensity equation is given, whether it is free of charge or not, that we have to find out. Now, if the region is free of charge, when it will be free of charge? When the region will be free of charge, friends? Yes, please. Whether for conductor it will be free of charge, or whether for insulator, dielectric, it will be free of charge?
Insulator.
For the insulator, it will be free of charge, is it not? So, if it is free of charge for the, it is the equation that we have derived for the Poisson and Laplace equation. What we have considered there? Free charge region, or the region free of charges, right? If it is a dielectric medium or an insulating medium, then it does not consist of free charges. They are all bonded to each other. In such a region, the volume charge density rho v is 0 for the dielectric medium. Rho v, volume charge density, is 0 because there are no free charges. If rho v is 0, then what is the equation, students? Del square v is equal to 0, because if we substitute rho v is equal to 0 in this equation, then we are getting del square v is equal to 0. That means we have to ultimately show that del square v is equal to 0. Okay, we have to verify the Laplace equation. Once we verify the Laplace equation, del square v is equal to 0, it indicates that it is having no free charges. If del square v is not 0, then it means there are free charges. Right? These are the two inferences that we can draw here. If del square v is 0, that means the region is free of charges. If del square v is not 0, that means the region is having certain charges. Okay, let us do that quickly. We know the equation between electric field intensity and the potential, that is electric field intensity is negative gradient of the electric field potential. E bar is equal to minus del V. That is 5 cos Z. E bar is given 5 cos Z A Z bar. Substitute here in this equation. That is equal to minus del V. Therefore, del V will be equal to minus 5 cos Z A Z bar. Am I right? Del V will be equal to minus 5 cos Z A Z bar. So find out del square V now. Del square V, how it is written? Del dot del V. Del square V is nothing but divergence of the gradient of potential. Del dot del V, this is nothing but the del square V. So del dot del V, it is known here, it is there in the equation, minus 5 cos Z A Z bar. We know that del square V for Cartesian, okay, or del for Cartesian, it is dou by dou x ax bar plus dou by dou y ay bar plus dou by dou z az bar dot of minus 5 cos z az bar. What is del, students? Del operator, its equation is given by dou by dou x ax bar plus dou by dou y ay bar plus dou by dou z az bar dot of this equation minus 5 cos z az bar. Okay, now here there are no x terms on the other side. It is only having z component here, minus 5 cos z az bar, only az bar component is there. There is no x component, there is no y component. So here dou by dou z of az bar dot az bar, az bar dot az bar is 1, correct? Az bar dot az bar is 1. If we dot any unit vector with itself, we'll get it as 1. So when az bar dot az bar is 1, what is remaining? Dou by dou z of minus 5 cos z, dou by dou z of minus 5 cos z. Now differentiate this with respect to z. So if we differentiate minus 5 cos z, what we will get? Minus 5 is constant, take it outside. Then differentiation of cos theta, it is minus sine theta, correct? So it is minus sine z. This will be equal to 5 sine z. Whether we are getting del square V as 0? No. We are not getting del square V as 0. That is, del square V is not equal to 0. Hence, the potential field in the region is not satisfying Laplace equation. Potential field in the given region, what the region they have given, it is not satisfying the Laplace equation. So we can say that rho v, that is volume charge density, is not equal to 0. Thus the region is not free of charges, or it does not consist of free charges. Okay, it is, if it is dielectric medium, then rho v would have been 0, correct? Rho v would have been 0. But as rho v is not equal to 0, it indicates that the region is not free of charges. Okay, that means it does not consist of free charges. It does not consist of free charges. Okay, am I right? Yes, students. Del square v is not equal to 0. Del square v is 0 for charge free region. Here we have got del square v not equal to 0, so it is not charge free region. It is not charge free region. That's all. Simple. Del square v is equal to 0 means it is for charge free region. Region free of charges, that is bonded charges, right? For that it is del square v is equal to 0. If del square v is not equal to 0, it does not consist of free charge in the region. Okay, not free charge free region. Am I clear here, students? Yes, please.
Yes, sir. Sir.
Okay, fine. One more example you'll take and try it for homework, students. Take this equation, sorry, the example. Given the potential field V is equal to 3x square yz plus k y cube z volts, find k if potential field satisfies Laplace equation. And second part is find E bar at 1, 2, 3. Note down the problem statement so that do it as homework. I'll check in the next class. I hope everyone took the example statement. Yes. Solve it
Yes,
for
sir.
homework. Okay, fine. In today's class, we have discussed one of the important derivations of Poisson's and Laplace equations, starting from the Gauss law in point form, and we have arrived at the equation del square V is equal to minus rho V by epsilon, which is the Poisson's equation, and del square V is equal to 0 for the Poisson's equation. Now, instead of asking directly students, another way of asking the question in examination is they will give you this equation. Derive the equation del square V is equal to minus rho V by epsilon. Okay, derive the equation del square V is equal to minus rho V by epsilon starting from the Gauss law in point form. So first you will have to identify which equation it is. Del square V is equal to minus rho V by epsilon is the Poisson's equation, right? After identifying, so it is in Poisson's equation, you have to start from the Gauss law in point form, del dot d bar is equal to rho V. Then go step by step. Okay, so that is how they can ask. Then they can ask, derive the equation del square V is equal to 0, starting from the Gauss law in point form. So you have to identify that del square V equal to 0 is Laplace equation. It is a Laplace equation. Okay, and then accordingly you have to derive from the beginning through the various steps. Okay, so these are the various ways in which they can ask. Sometimes they will ask the end equation, whatever we have obtained here. Sometimes they may ask the intermediate equations in the examination, like del square V is equal to minus rho V by epsilon is an intermediate equation, important equation. Okay, so they may ask intermediate equations or they may ask end equations. This is one way. Another way of asking is direct questions. That is, derive the equation for Poisson's and Laplace equations starting from the Gauss law in point form. This is a direct question. Instead of this, they will give the equation sometimes and they will ask. Sometimes they will ask the direct question, the statement of the question. Okay, these are the various ways in which they can ask. This holds good for the other topics also. Del square operation in different coordinate systems. These formulas you all have to remember here for Cartesian, cylindrical, and spherical. Somehow you try to write these repeatedly so that you'll be able to remember, right? Repeated practice. Try to write it for 4 times, 5 times, okay, and try to memorize. Otherwise, what you all can do is write these equations, stick it on to your study table wherever you sit for studying, and whenever you go to study table, just go through these equations. Right? Just read these equations repeatedly, so that repeated reading makes your memory stronger. Okay, that helps to remember the equations. Right? Then we have solved two examples on the Poisson's and Laplace equation. Okay, so in the next class we will solve this numerical. We'll check this numerical which I have given for homework, and then we'll continue with the uniqueness theorem. The next one is uniqueness theorem that we'll take up in the next class. Okay. So here the basically it is a mathematical equations that you will have to know here. Okay. Once you all know the mathematical equations and the concepts, then you'll be able to solve any of the numericals, and even for the derivations also. Mathematical background is required here. So this subject requires mathematical background. Right? Mathematical background is needed. So once the mathematics equations are aware of, if you are aware of the mathematical equations, it becomes simpler to get the derivations done or to solve the numericals. Okay. Prathamesh, any difficulty in understanding? Prathamesh,
No, sir.
clear today's
Yes, sir.
discussion?
Yes, sir.
Okay. Okay. Suraya Banu,
Yes, sir.
clear with the today's derivations, examples?
Ah, yes, sir.
Okay. Ankita,
Yes, sir.
clear today's derivations, Ankita, numericals?
Yes, sir.
Okay, fine. John, Kalarkoppa, John. Sridhar, Patil, Sridhar. Okay. Suraya Banu.
Yes, sir.
Was it understood, Suraya Banu, today's discussion?
Yes, sir.
Okay. Vishal.
Yes, sir.
Vasulkar. Clear today's concepts, Vishal?
Yes, sir. Yes, sir.
Okay. Sankalp.
Yes, sir.
Was it understood? Any difficulty, any problem in understanding, Sankalp?
No, sir.
Okay.
Understanding, sir.
Okay, fine. Good. So I'll continue in the next class, students, with the new topics. Thank you.
Sir. ಯಾಕೆ ಸಲ ಇಡಕತ್ತಿ
ಕೀರ್ತಿ ಹೇಳ್ರಿ.
ಸರ್ ಹಾ ಸರ್
ಹೇಳು ಕೀರ್ತಿ.
ಗಾಸ್ ಲಾ ಆದ್ಮೇಲಿಂದ ನೋಟ್ಸ್ ಕಳಿಸ್ತೀರಾ ಸರ್ ಸ್ವಲ್ಪ?
ಕಳಿಸ್ಕೊಡ್ತೇನ್ರಿ. I'll send the notes.
ಸರ್ PPT ನೀವು ಮಾಡಿದ್ದಾದ್ರೂ ನಡೀತದ, ಇಲ್ಲಾಂದ್ರೆ ರಿಟರ್ನ್ ನೋಟ್ಸ್ ನಡೀತದ?
Sure, 100%. I'll send you. Okay, fine. Anything else you want to ask?
Yes, sir. Thank you.
Okay. Yes.
No, sir.
Okay, fine.